So everyone, we are going to discuss question number 37. So in this question, you can see from x1 to x7 are given IID following normal 0, 1, and you have to find the distribution of this one. I'm going to write it root 2 x5 minus x6 plus x7 and whole upon root of x1 plus x2 plus x3 whole square plus 3 times x4 square. Now this is a very easy question. So first of all, what we are going to do, we are going to find the distribution of this numerator and this in the denominator. So this is very easy. If you know the concept, if you have learned the chapter number 9, which where we have discussed the all about the continuous distributions, there is a normal distribution as well. So as for my paid batch student, you all know it because we have already learned it in our live classes. So we know that how to use the properties of a normal distribution or a standard normal variate. Now from this everyone, we can easily write it that x5 minus x6 plus x7 follows normal distribution with mean 0 and variance 3, as well as we can also write that x1 plus x2 plus x3 also follows normal distribution with mean 0 and variance 3. And now we are going to rearrange it. So rearranging it, what I can write, I'm also giving it a new notation. Suppose this is represented by t and this is represented by t dash. Okay, so I'm just going to make this t as the standard normal variate because this is the t written in the numerator. So what I am going to do, I'm going to write a t at the place of it and also subtracting 0. And now what I'm going to do, I'm going to divide the numerator and denominator by 1 by root 3. Okay, now under root, at the place of this, I'm going to write a t dash and there is a square of t dash plus this is 3, this is x4 whole square. Now you can see I'm going to take this root of 3 inside. So what we can write, root 2, this is t minus 0 root 3. And now you can see it is representing a standard normal variate, because what is the form of a standard normal variate? X minus its mean upon standard deviation. So you can see this is the same form. There is a root 3 in the denominator, which is representing sigma, right? And now in the denominator, what we can write, I'm going to take this root 3 inside this root. So root 3 going inside the root will be, there will be square of this root 3. So what we can write, I'm going to write t dash whole upon root 3. There's a whole square, and also I can write minus 0 because it will not affect it. Now plus I have to multiply 1 upon root 3 whole square with the second term. So we can cancel out that root 3, that 3 from the numerator and 3 from the denominator, and there is x4 whole square. Okay everyone, now after that what we are going to do, now you can see this is representing our standard normal variate. This is a standard normal variate, right? And this is the square of a standard normal variate. Again, this is the square of a standard normal variate, right? So in numerator, we can write this is your normal 0, 1 representing, and this is this and this representing your chi-square variate with 1 degrees of freedom. But this is separate chi-square 1, this is separate chi-square 1, and sum of 2 chi-square variate with 1 degrees of freedom means chi-square with 2 degrees of freedom. Okay, so finally I am going to rewrite it. So what I will write, root 2, this is normal 0, 1, and in the denominator what we can write, this is chi-square with 1 degrees of freedom plus this is chi-square with 1 degrees of freedom is equal to, this is your normal 0, 1, and this is your root 2, and this is your chi-square with 2 degrees of freedom. And now I'm going to take this root 2 in the denominator. So we have now normal 0, 1 and root of chi-square distribution with 2 degrees of freedom divided by 2. Now you can see this is a form of a t distribution. Okay, so this is representing that this ratio follows t distribution with 2 degrees of freedom, because this is a property in your mathematical statistic of Gupta and Kapoor, where the ratio of standard normal variate to the root of chi-square variate divided by its degrees of freedom, right, follows your t distribution with the same degrees of freedom. If suppose we have n here, so that means it will follow t distribution with n degrees of freedom. But right now we have 2 here, so it will follow 2 degrees of freedom, and there should be standard normal variate in the denominator. So I hope everyone you all like this solution, and do let me know if you have any confusion. And if you want to join my live classes, you can contact me on WhatsApp, the Instagram, as well as all the information is given in the bio. So thank you everyone for watching this video. Have a nice day.